Hello, in this video we are going to explain about our GNN project, which is node classification task on OGBN products dataset. The OGBN products dataset consists of undirected unweighted graph of Amazon product co-purchasing network. That is, if two nodes are purchased together, here nodes represent the product, and if two products are bought together, then there is an edge between those products. In this we obviously get the nodes and edges, and as well as get the initial node embeddings. Initial node embeddings are nothing but a bag of word features which are generated using product descriptions and based on product categories. Later they are brought down to a lower dimension, that is a dimension of 100, using principal component analysis. Here first, coming to our task is to predict the category of the product using multi-class classifications and node embeddings. The number of classes are 47. Coming to the code, first we import the necessary modules and also the open graph benchmark library. The save embeddings function is to just save the model and run later. Here for device we are using the GPU, and these are the default parameters which can be tuned, but we prefer to use these ones. I will explain some of them. Like we can train for some more epochs to get better accuracy, but because of limit of time we have only used one epoch, and batch size is 128, and learning rate around 0.01. And walk length is 20. That is, we would for Node2Vec we have chosen for a path we would choose a 20 walk length. And embedding dimensions we are choosing embedding to be 64. Here we are loading the data set. Then we are using the Node2Vec model from PyTorch geometry. And we are also loading the data into data loader form. Then for optimizer you are using sparse atom optimizer with learning rate. Then we are training the model, and for each epoch we are importing the loader from loader, and optimizer.0grad is initially making all those grads to 0, and then we compute the loss and propagate the loss backwards and update the weights. And we would do this every time, and for every log steps I am printing the epoch and the loss. And at final I am also saving the model to use later. We can see that initially the loss is around 6.7, and later it is decreasing, and in one epoch itself the loss has significantly decreased. We can use much more epochs. Then later we got the node embeddings from the model, and after we get the node embeddings from the model, we can use any classification, any multi-class classifier. We can use like logistic regression, decision tree, or even a multi-layer perceptron. In this case we choose to use decision tree because it is much faster. We are converting from tensor to numpy array, and then we are splitting the training and test set into 0.8 and 0.2 with a random state 10, and then we are creating a decision tree with max depth 8 and fitting the test and train set, and then predicting the test set. We can get the results based on any metrics we want, like confusion metric or accuracy. Here we can see that we got an accuracy of 77%, which is actually fine. So we can say that instead of directly using the bag of words model, if we use Node2Vec, our accuracy would be much higher than normally using the initial embeddings of just bag of words. Thank you. Hello, I want to convey some additional points. So first let us look at the initial dataset. As I have already told, this is the dataset from Amazon product co-purchasing network, and the edges are brought together. and the nodes are just extracting bag of word features, and they are brought down to lower dimension using principal component analysis. And there are 47 total level categories of products which we use for classification. And here they actually made it a challenging one, because instead of just randomly assigning 90% of the nodes to training and 10% to the testing, they actually used a different method. Like we can see, they use sales ranking as popularity, and sorted those according to sales ranking, and use the top 8% for training, and the next 2%, 80% for training, and then 20% for validation, and the rest for testing. This is a more challenging splitting procedure than the real life world application. Now, actually, let us compare our model with others' model. Uh, we can see that actually they have a very high accuracy of 90%, and but later as we go down, the accuracy slowly moves down, like around 80s and 90s, and later even 70s. So actually, here they would use very high algorithms like ENGCN and etc. But later we can see even they use Sage plus uh, MLP or normal GNN, etc. So we can say our model is not as good as them, but at least we can say that it was similar to around 50th position. Like we use Node2Vec similar to them. Uh, if we have used grass sage, maybe then our model would have performed better. But because of the time constraint, we wouldn't actually test it for those. But it was better than using a just plain old MLP, which was around just 61%. So using graph algorithms was definitely better than standard machine learning algorithms. So we can improve our model, but it is not as bad as we think. Thank you.